Okay, so this is a chapter where in the very beginning I have a lot of definitions, and then at the end I have a lot of formulas. So this is going to be a very carefully written notes, I'm hoping, by all of us, and a lot of formulas that we're going to be using over and over and over again. So this is really important video for us to watch. I'm going to begin with some important vocabulary, okay? So, the vocabulary that we want to talk about are all, we'll just say, we'll give you the word over here on the right, and then I'm going to give you like a little example of what I mean on the left, and then an example of what I mean on the right. So, a trial would be each occasion where we observe random phenomena. And what I mean by that is basically like a random event occurring. But the term event is one of our vocabulary words, so we don't use that in a second time here. So let's say an example of a trial would be, let's say we want to flip 2 coins, right? So the trial would be flipping both coins, right? So flipping the actual, both of them. Each occasion where we observe the random phenomena, and in this case we want to flip them both, okay? So an outcome would be the value of the trial, right? So the value of the trial, okay? So for the random phenomena. So in this case, sorry about my dogs. They don't really need to go outside. They're just looking at squirrels in the backyard. So the value of the trial for the random phenomena. So when I say the value, right, I don't know how I stopped recording, so I'm not really sure where I stopped. But I'm on outcome, okay? And when I say value, I mean actually getting heads or tails on each flip, right? So like an H or a T or something like that. So maybe like H or T for representing heads or tails. Now the word event, though, specifically means a combination of a trial's outcomes. So an event might be heads, oops, that's supposed to be an H, heads and then tails, for example, right? Just one possible event is heads and then tails, all right? And then the sample space, oh goodness gracious, which is written usually as a capital letter S, is the collection of all possible outcomes. And then the way I like to write this is listed as events. So what I mean by that is that the sample space, in this case, and then I will let my dogs out so they stop. Nope, I'm just going to do it first before I finish the sample space. I'm going to use fancy bracket notation. And my sample space is going to consist of all the potential outcomes that I could have, but I'm going to list them as events. So remember that my event was both coins being flipped. So if I started with my first example event, which was heads, tails, then maybe my next one was tails, heads, and then my next one might be both heads, and then finally tails, tails. And so those would be my 4 total options in my sample space. And then this whole concept of probability, right, is that we have another event that we're looking at. So we're always looking at our sample space. This is very important to know the total number of outcomes. But it's also important to know what we're assessing. So an example might be, what is the probability of flipping two heads, right? So both heads. All right, so the definition of probability is, oh, maybe I should move to the next line down. So I'm going to move down here. The definition of the probability of event A, which in this case is flipping two heads, we write it with this fancy notation, capital P of A, which just means the probability of event A. And it literally means the number of outcomes in A over the number of possible outcomes. So if we're talking about flipping two heads, then event A would look like this. Only flipping two heads, but the sample space was heads, tails, tails, heads, 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 and tails, tails. So the probability here is only that one event out of the four potential possible events. Okay, so a couple things that I think that like the most important definition on this slide is probably this one, right? Where we're talking about the probability of an event occurring, just to try to understand the general idea behind it, because on the next slide, we start to talk about the rules of probability, and there are several. So I want us to kind of pace ourselves here. If you need to pause, pause, because now I'm going into the rules of probability in the next slide, okay? So let's go back to a black marker and we'll say, here are the general rules of probability. And there are five rules, and then we expand on them later, okay? So the first rule is that all values of the probability of any event, no matter what, must fall between 0 and 1. All probabilities lie between 0 and 1. It's possible to equal 0, which would mean that this event will never happen. It is also possible to equal 1, which means that this event is definitely going to happen. But in general, probabilities lie somewhere between those two values. And then this whole concept of the sample space for this capital letter S is that it contains all possible outcomes. So all possible outcomes are in the sample space. So it has a probability of 100% or 1, right? It's certain to happen because it contains every possible outcome. It's a weird one, but it just means that everything's in there. Okay, the next three rules actually have names. This one's called the complement rule. And it says that A complement, that's how we would read this, but we would write it like this, A with a bar over top of it, is equal to everything not in A. So when we think about, in our previous slide, we said getting two heads was event A, right? Then the complement of that is not getting two heads, or heads, tails, heads, and tails, tails. So it's literally the opposite of this event, okay? So it's everything that's in the sample space that's not in event A. So it's not in A, but is in the sample space, right? So the idea behind the complement rule is basically that the probability of A plus the probability of A complement have to equal 1. So this is basically saying that A and A complement make up the sample space. They contain all the possible outcomes. But the way we typically would use this formula is that we would rearrange it, and we would say that P of A complement is equal to 1 minus P of A. So we would take our value and subtract from 1. So we'd literally say 100% minus the probability of the event A. Okay, and then I'm also going to box up the fact that all probabilities have to lie between 0 and 1, and the probability of the sample space is equal to 1, because those are all of our rules so far. We get to see all these rules in class, but it's so important to kind of like see them ahead of time and have this potential idea of how they might be used. Rule 4 is the addition rule, where we would say that the probability, and this is very specific to events that have nothing in common, but let me write the rule first. The probability of A or B is equal to the probability of A plus the probability of B if A and B are, and we refer to them as disjoint. Okay, so this addition rule has a caveat. It works, P of A equals P of A plus B, but I need to kind of box in the rest of that because I need to make sure that A and B are, quote, disjoint first. So let's describe that underneath. Disjoint means that these two have no, well, let's not even say two, because it could be possible for more than two. The sets have no outcomes in common. So an example would be flipping two heads would be like event A, and flipping exactly one tail would be event B, and they are disjoint. There's no way for me to flip only two coins and get exactly two heads and exactly one tail at the same time. It's not possible. Okay, so this is something that we want to keep in mind too. Sets that have no outcomes in common, right? They have no overlap. They're not possible to occur at the same time. Cannot possibly occur at the same time. That's what disjoint really means. Okay? All right, and then I have a fifth rule, and then I'm going to stop and do another video for the more extended rules. So finally, rule number 5 is called the multiplication rule. Whoa. I'm supposed to say multiplication rule. And yes, you're right, we multiply, but this changes. It says P of A and B would equal P of A times P of B, but we have to make sure if A and B are independent. So now we have another caveat. This is getting annoying, right? Don't worry, at some point we have rules that work every time, but in the beginning we just introduce the general rules. And then remember that we have this idea of independent, but independent really means one event has no impact on the other. So if these two events truly are unrelated and do not impact one another, then I can multiply the probabilities together if I want to talk about them happening at the same time. Okay, I'm going to pause here and I'm going to do another video for the general rules for these formulas.